Hello everyone. So without wasting much time, we are going to start our first chapter. This year we'll be following conscience chemistry, that is of Selena publications. So we are directly moving to the first chapter. So the first chapter is periodic table, periodic properties and variation of properties. It is a chapter that is a continuation of whatever you are studying in 9th class, that is periodic table. So it is good if you are just going through the ninth class chapter, that is periodic table, before going through this live, or just after this live just go and read the 9th class textbook, then just go through the video once again. Now, before going to the main parts of this chapter, it is good if you are having a book with you, a notebook where you can write down the important points, and also a periodic table from any textbook or anywhere else. I suggest that you are having that with you, because you are supposed to go through the elements when I am explaining all the important stuff in this chapter. Okay, and before entering to the main portions of this chapter, let me give you a brief introduction. Last year you have studied various type of classification like Dobrinus, Treyarch, Mendel's periodic table, but Newland's law of Octavius. All these things are not needed in your 10th class. You'll be studying something new. You don't need any other. You don't have to study any of the laws that you have studied in the last class, except one, that is the modern periodic law. You need to remember that according to the modern periodic law, physical and chemical properties of elements are periodic functions of the atomic numbers, not atomic masses, atomic numbers. You just need to remember the modern periodic law that is put forward by Mosley. Now, other than that, you need a idea about what is a group, what is a period, all the details about the modern periodic table. Only the modern periodic table is important. In this chapter, you are only going to study about the modern periodic table. So, what is a group? Vertical columns are called group, horizontal rows are called periods. You have studied the significance of groups and period in the last year. So, as you remember, the groups, it indicates the valency of an element, or it signifies the valency of an element. In other on the same way, the periods, it denotes the number of shells that is present in that particular element. Okay, now we are moving to the first part. Okay, as you know, this chapter, it is about periodic properties, or variation of periodic properties that is there in the periodic table, modern periodic table. So in the last year you have studied about various periodic properties, not much, just little bit of explanation was given in the last year's textbook. The periodic properties that you are going to study here are atomic size, electronegativity, electron gain enthalpy, ionization energy, metallic character and non-metallic character. So I think you remember you have studied the definition last year, but this year you are going to study it properly. You are going to study how there is a trend or change according to the periodic table. Okay, so the first periodic property that you are going to study, it is atomic size. But before going to any of the periodic properties, you are supposed to study a little bit extra that is not mentioned much in the textbook. So it is about the nuclear charge. That is the most important thing that you need to discuss while studying this chapter. And before that, just look into the rough periodic table that I have shown. I haven't drawn any elements on that. Just go through this. So there will be two important words that will be used in this chapter. One is moving across the group and moving down the group, moving across the period and moving down the group. So other than that, there are many other down the below means we have to go down from the topmost to bottom of the periodic table. Now we are going back to the nuclear charge. So before going to the nuclear charge, just assume a magnet. Okay. So we are taking one piece of magnet and so two pieces of magnet, we are arranging it likewise. Suppose I am having these two magnets in my hand. So if I am bringing it closer, I can feel the attraction between the two magnets in my hand. Okay. So since these two magnets are almost equally powerful and it is having almost same size, I can tell that the force I feel in my both hands is almost similar. Okay. Now I am going to change one of this magnet, and in the second case scenario I am going to take a larger magnet which is more powerful and a smaller magnet which is less powerful. Okay, so in this case what will happen if I am taking the larger magnet in my left hand and smaller magnet in my right hand? This is what that is going to happen. The smaller magnet in my hand, it will move towards it is having much more tendency to move towards my right hand compared to the larger magnet which will move towards the right hand. Okay, so definitely the larger magnet will attract the smaller one towards itself because it is having more power compared to the smaller one, and also the size is also larger. Now it is not like just one magnet can be attracted towards the larger magnet. If you are having more number of magnet, it can also be attracted towards the larger magnet. Now you just have to keep that in your mind while going to the next concept, that is nuclear charge. But before that, I have to explain a little bit about the atomic size. That is the first periodic trend or periodic property that we are going to discuss in this chapter. So atomic size. So what is the size of what is an atom? An atom, it contains proton and neutron inside the nucleus, and there are some electrons that is revolving around the atom in the orbits. Okay, so electrons are negatively charged, protons positively charged, neutrons neutral. Okay, so what is the atomic size of this particular atom? So if you are considering that the atomic size, it is the distance from the center of atom to the electron in the valence shell. Okay, it is the distance between the center of an atom to the valence shell of an atom. Okay, now keep that in mind. We are going to going for the next one, that is nuclear charge. So just consider the lithium nucleus. It is containing 3 proton and 4 neutron. Actually 4 neutron. Actually the neutrons are not important. You just have to consider the charge of the nucleus, that is 3 positive charge. If you are considering some other nucleus, hydrogen, it is having 1 proton, 2 proton for helium, 3 proton for lithium, 4 proton for beryllium. Okay, so here the nuclear charge, it is a charge of nucleus, or in other words the total charge of nucleus. If you are looking at the example, we can see that the nuclear charge, it will increase if the atomic number is increasing, or in other words, if you are moving from anywhere from hydrogen in the periodic table, you can see that the atomic number increases, or in other words the charge inside the nucleus, it will increase. Now nuclear charge, it is the total charge inside the nucleus, or in other words it is the total number of positive charge inside the nucleus. Now if you are considering the first period, that contains hydrogen and helium, the first one is hydrogen, of course. Now in this one there is 1 proton and 1 electron. So this electron will be attracted by 1 single proton that is inside the nucleus. The next one, it is helium. It is having 2 proton and 2 neutron inside the nucleus. And in the first shell there Okay, so just remember what I told about the nuclear charge and about that magnets. Here, the nuclear charge inside the hydrogen atom, it is 1. Here, the nuclear charge inside the helium atom, it is 2 positive. Okay, so you have to consider it like two smaller magnet and one large magnet and small magnet, that concept. So it is like this. In case of hydrogen, there is one positive charge, one negative charge. There is almost equal force of attraction. Now in case of helium, there is this thing. It is a large positive charge and two smaller charges. Okay, so two smaller negative charges. So it will be like this. The larger positive charge, it can attract more electrons, or in other words, this nucleus which is containing larger nuclear charge, it can attract the electron more effectively compared to the previous one which is having less nuclear charge. So in other words, this electron, it will be attracted towards the nucleus more powerfully, so the electrons, it will come closer, or else you can tell that the size of the atom, it decreases if the nuclear charge is increasing. Okay, so I hope you understand. I will give one more example, that is of lithium. It is having 3 proton and 4 neutron. So if you are considering it is having 3 proton and 3 electron, 4 neutron. So if you are considering this, there are 3 proton, there are 2 proton. So the nuclear charge of lithium is much more compared to the nuclear charge of that of helium. Okay, lithium is having more nuclear charge compared to the lithium nucleus. So lithium nucleus is having much more nuclear charge, so it could attract, if there is no other factors, it could attract the electron more efficiently compared to that of helium. Okay, so if I am drawing the size of atom in the second period, it will be almost likewise. This is our lithium. It is having almost this size. So the next one is beryllium. Lithium was having 3 protons inside the nucleus. Now the beryllium, it is having more number of protons inside the nucleus, so it is having more nuclear charge. So when the nuclear charge increases, what is decreasing? The atomic size will decrease. So if you are drawing beryllium, the size of beryllium will be smaller than that of lithium. So after beryllium, there is boron. So size of boron, it will be smaller than the beryllium. So after boron, carbon, nitrogen, oxygen, fluorine. Okay, I am drawing only up to fluorine. Noble gases are having some exceptions. You will study that later at the end of the chapter. Okay, so if you are going from lithium to fluorine, what is that? Lithium to fluorine. We are moving across the period, or if we are going from left to right in a periodic table, what is happening? Nuclear charge is increasing. So whenever the nuclear charge is increasing, the nucleus is able to attract the electrons more powerfully. So the electrons in the outermost shell, they will come closer, or in other words, the size of the atom, it decreases when we are moving from the left to right in a periodic table. Okay, so as you conclude, if we are moving from left to right in a periodic table, atomic size decreases. So we are moving to the next part under the heading atomic size. So you have studied that whenever the atomic number or the protons are increasing, the nuclear charge, it is increasing. Okay, so because of that reason, if you are moving from left to right in a periodic table, nuclear charge increases, so the atomic size, it is supposed to decrease, or it is actually decreasing. Now the next category that you are going to study, it is when we are moving down a periodic table. So when we are moving down a periodic table, for example, you have to consider a group and and you have to consider all the elements in the same group. Okay, for example, the first group we are having hydrogen, lithium, then we are having sodium, potassium, and so on. Okay, so if we are considering these elements, the first element, that is hydrogen, it is having one proton. So the second element that is mentioned here, it is lithium, it is having 3 protons. The next one is sodium, it is having 11 protons, and potassium, it is having 19 protons. So if you are going according to the previous terms, you can just predict that if you are moving from top to bottom in a periodic table, definitely the size is going to decrease, but it is not decreasing, instead it is increasing. There is another reason for that. So the another reason, it is due to the number of shells that is increasing. So I'll be explaining about that here. So the first element in the first group, that is hydrogen. So if you are considering hydrogen, there is one proton and only one electron. Okay. Now the next element in the first group, that is lithium, it is having 3 proton, 4 neutron inside the nucleus. So what happens here is, suppose if the electrons are, if all the 3 electrons were in the same shell, then the nucleus would have attracted the electrons more properly and the size of the atom must have decreased. But the problem is, more than 2 electrons, it is not able to stay in the K shell. The number of electron, the maximum number of electron that K shell can accommodate is 2, and it is more than 2. So definitely when we are starting a new shell, or in other words, the reason is because if this electron is coming closer, it is not able to occupy the space between the nucleus and the other shells or other electrons. So because of that reason, when a new shell is introduced, even though the nuclear charge is increasing, because the electron is not able to come more closer, the atomic size is increasing. Okay, so when you are writing the explanation about the atomic sizes, you don't have to explain about all that magnet and all the stuff. The only thing that you have to explain, it is based on the nuclear charge and about the shells. Okay, so the definitions and the questions based on this will be likewise. Why atomic size it is increasing from left to right in a periodic table? The explanation is this: when we are moving from left to right in a periodic table, nuclear charge is increasing. You can write it likewise also. Atomic number is increasing, number of protons is increasing, nuclear charge is increasing. So the nucleus is able to attract the electrons more powerfully. The electrons will come closer towards the nucleus. Atomic size decreases. Now, if you are moving from top to down in a periodic table, what happens is this: nuclear charge is increasing because the number of protons are increasing, but there is also one more effect, that is this: number of shells is also increasing. No other more than that particular value of electrons cannot be accommodated in the same shell. So after explaining these two facts, we have to explain one more thing. The number of shells, the effect of number of shells predominates or dominates over the nuclear charge. Because of that reason, it is actually because there are two reasons. The nuclear charge, it is decreasing the size of the atom, and the increasing shell effect, it is increasing the size of an atom. One effect it will try to decrease, and other effect it tries to increase. Here the increasing number of shells, it is more dominant over the nuclear charge. So definitely, instead of decreasing the size of the atom, it is increasing. Okay, so when we are moving down the group, the atomic size, it is increasing. Okay, so just look this diagram. Okay, you can see that from top to bottom, the size of the atom, it is increasing. if you are moving from left to right in a periodic table, size of an atom, it is decreasing. Okay, so all this explanation is not necessary, just one or two points is enough. Nuclear charge increases, decreases. Now new number of shells is added, no new number of shells is added. Which effect predominates, or there is no other effect to cancel out. That much is enough for the explanation part. Just 2 points are enough. Now I hope you understood the first part, that is atomic size. Okay, we are moving to the next periodic trend, that is metallic character. Okay, you have studied about metals and non-metal in your smaller classes. So in that you have studied that metal is having the property of luster, it is having electrical and heat conductivity. There are many other properties of metal, and in one of that property, that is chemical properties, you have studied something that metal is having an electropositive character. Or in other words, what is electropositive character? It is the ability of a metal to donate the atom, to donate the electrons. Okay, so this metallic character, it means the ability or a tendency of an atom to donate electron. Okay, to donate or lose electron. Okay, so metallic character is the ability of an atom to donate or lose electron. So just go look into the periodic table. So if you observe the periodic table, just okay, go through the third period. The first one, it is sodium. So you know that sodium is a metal. So sodium is a metal. So the next one, it is magnesium. Magnesium is definitely another metal. After that there is aluminium. It is also again another metal. And after that you can see silicon. Silicon is not a metal, right? It is a metal ore. Okay. So after that, whatever elements that is coming, they are non-metal. So if you are moving from left to right in a periodic table, if you are moving across a period in a periodic table, on the leftmost side you can see the metals, then in between metalloids, and at the end non-metals. So the metallic character, you can guess where it will be more. Okay, it will be definitely more on the left hand side of the periodic table. It will be less in the right hand side of the periodic table, because that side it is non-metal. So metallic character, it will be more in the leftmost side, it will be less in the right hand side. Okay, so we'll discuss why the tendency is so and so in the periodic table. So just now we have discussed about atomic size. The atomic size is most important compared to all other periodic trends. The reason is because from the whatever new trends that we are studying will be explaining based on atomic size and nuclear charge. So here also we are going to discuss the metallic character based on the atomic size and nuclear charge. So you already know what is happening to the atomic size and nuclear charge. The explanation is more simple compared to that of atomic size and nuclear charge. So in case of metallic character, just consider a large atom. Okay, a large atom means it is having a nucleus which is not attracting the outermost electron properly. In other words, the atom is larger because the attraction between nucleus and outermost electron, it is not that much high compared to a smaller atom. Okay, so if the size of atom is big, in other words, if the size of atom is big, it means the outermost electron is loosely held by the nucleus, or in other words, it is easy to lose that outermost electron. Okay, so wherever you are having the larger atom, it is easy to remove the electron from that particular large atom. In opposite sense, if the atom is having smaller size, it means that the nucleus is attracting the valence electron more properly, and it won't be easy to remove one electron from the outermost shell of an atom. So just now we have discussed about the atomic size. So if the atomic size is increasing, it means that metallic character it is also increasing. So more the atomic size, more the metallic atom. So if you are just telling the opposite, if the atomic size is decreasing, that means the metallic atom it is decreasing. So you have just drawn a diagram in which when we are going down a group, atomic size is increasing. So if we are going down a group, atomic size is decreasing means, atomic size is increasing means, when we are going down a group, nuclear charge, the metallic atom it is also increasing. So next one, it is based on it is when we are moving from left to right in a periodic table. So when we are moving left to right in a periodic table, atomic size decreases. Atomic size decreases means metallic atom it is just opposite. If atomic size is decreasing, so it is just the same. If atomic size is decreasing, it means that metallic atom it is also decreasing. Okay, so when we are moving from left to right in a periodic table, metallic atom decreases. When we are moving from top to bottom in a periodic table, metallic atom increases. Okay, so after the metallic atom, the next periodic trend it is just opposite of what we have learned, that is non-metallic atom. Okay, so the metallic atom it was the ability of an atom or tendency of an atom to lose electron. So non-metallic atom it is just opposite. It is the ability or tendency of an atom to gain electron. So if you are you are studied before that non-metals it is having electronegative tendency, or in other words it is having a tendency to gain electron compared to that of metal. Okay, in case of metal it was electropositive property, non-metal electronegative property, or in other words the tendency to gain electron. Okay, so in case of if you want to gain electron, you need, it is like this is more predominant for non-metals. So if you look at the periodic table, you can see almost all the non-metal they are lying on the right hand side of the periodic table. And one more thing is the almost all the non-metal they are lying in the top right corner. Okay, so near the helium or fluorine sign. Okay, so the top right corner they are having maximum non-metallic atom. So if you are explaining it based on the non-metallic atom, it is the ability to gain electron. So to gain electron, suppose you are considering a larger atom, just like the case of metallic atom that we have discussed. You are considering a large atom. Large atom means what? In the nuclear charge, it is not able to attract the outermost electron properly. So the outermost electrons are loosely bounded. Suppose in that condition we are giving one more electron to the valence shell. Already the nucleus is not able to attract the outermost electron properly, and again we are adding one more electron. So it is not like the nucleus will be able to hold. I am not telling that it is not possible, but it will not be easy for the nucleus. Okay, so the nucleus of a large atom it won't try to hold a electron in the outermost shell, hold a new electron in the outermost shell. So instead if you are considering a smaller atom means that compared to the other atom it is having more nuclear charge, and because of that and more nuclear charge and lesser number of shells. Because of that reason, what happens here is the nucleus is able to attack all the outermost electron properly. So already the outermost electron it is facing high amount of nuclear charge or high positive charge. In that condition, if you are adding one more electron, that atom is able to accept that electrons easily. Okay, so in case of if you are comparing with the size, in case of non-metallic atom, smaller the size, maximum non-metallic atom, larger the size, minimum non-metallic atom. So if you are going back to that diagram, if you are going down a group, atomic size is increasing. So if you are going down a group, if the atomic size is increasing, it means that non-metallic atom it is decreasing. Okay, now if you are moving towards the right side, atomic size is decreasing. So if you are moving towards the right side, the atomic size decrease means, in other words, non-metallic atom, it increases. Okay, I hope you understood this. This is just a continuation from the metallic atom. If you understood the metallic atom properly, just write opposite of the metallic atom. You will get all the required explanation for the non-metallic atom. The next periodic trend, it is ionization potential. There are many other names: ionization enthalpy, ionization energy. Okay, so this is one of the important periodic trend that is usually asked in the exam. Okay, so the definition of ionization potential, it is important. So the definition is atomic amount of energy required to remove the most loosely bounded electron in the valence shell of a gaseous isolated atom in its ground state. The definition, it is little bit bigger compared to the others. You are not supposed to skip even one word from that. It is important as such. Okay, so if you write that down, just write that down, study that entire sentence as such. Okay, in the textbook the definition is not proper. I don't think that will be acceptable by board. Okay, so just note down that definitions. Now I'll just explain what I have told. I'll explain the definition of ionization potential. Just consider one atom. This is the nucleus. This is the shells. I'm not okay. Okay, a nucleus is surrounded by 4 electrons, so it is definitely the beryllium atom. So we are going to find the ionization potential of this particular atom. For that, the first thing, it is supposed to be in gaseous state. Okay, so we are supposed to convert beryllium. Beryllium is a solid metal. So we are supposed to convert that into gas first. After converting it into gas, we are supposed to isolate a particular beryllium vapor, and after that what we are going to do is we are trying to remove one electron from beryllium atom. So there are 4 atoms already inside the beryllium nucleus. We are not supposed to remove any of the 4 electrons. Okay, there is a, sorry, it is not beryllium. Okay, now we are not supposed to remove any of these 4 electrons. You are not supposed to remove the K shell electron. The reason is, it is mentioned that you are supposed to remove the most loosely bonded electron. Okay, so definitely if you are comparing K shell and L shell, K shell is the shell that is closer to the nucleus, and definitely the nucleus, it will be having more attraction power towards the K shell compared to that of the electrons in the L shell. So the K shell electron, it will be more attracted by the nucleus compared to the L shell electron. So we are supposed to choose an electron which is least bound, most loosely bounded. So it is definitely not the electrons in the K shell. So it is one of these electrons. Okay, so we have to find which one of the electron among these two is most loosely bounded. And suppose this is the most loosely bounded electron, we are supposed to give energy in form of electromagnetic waves. So at a particular energy, what happens? You are studied according to the Bohr principle, Bohr model. So if you are giving a particular wavelength of energy, this electron, this electron can be removed after giving a particular amount of energy to the electron. So the energy that is required to remove this electron, which is the most loosely bounded electron, in the valence shell of an atom which is in gaseous state, it is called ionization potential. So almost all the elements is having their atomic ionization potential measured. So it is measured by this technique. Now this ionization potential, it is having some similarities with metallic atom. So what was metallic atom? It was the ability of an atom to lose electron. So here also we can see that electron was removed from the outermost shell. So if the atom is having an ability to lose the electron can easily be removed from the valence shell. So suppose you are considering an atom with suppose you are considering a metal, or in other words an atom with high metallic character. So it is like we can easily remove the most loosely bounded electron without giving much amount of energy, or in other words with just a small amount of energy you can remove the electron from the outermost shell. So since the energy required is small, ionization potential it will also be small. Okay, so in other words, if you are having a metal, it is easy to remove the electrons from the outermost shell, or in other words, very less amount of energy is required to remove the electrons from the outermost shell. So what happened? With very less amount of energy, we can remove the electrons. So for those elements which are having high metallic character, the ionization potential it will be very less. Okay, now just consider non-metal. They are not having that much tendency to lose the electron. They are having the tendency to gain electron. So if you are trying to remove an electron from a non-metal which is not having any tendency to lose electron, what we have to do, we have to give more amount of energy. So if we need to give more amount of energy, ionization potential, it is the measurement, it is amount of energy required to remove the electron. So if we need more amount of energy, so ionization potential of the non-metal, it will be more. Okay, so you have studied that metallic character, it is most on the left hand side, least on the right hand side. So just like the case, ionization potential, it will be more on the left hand side, it will be less on the metallic character, it will be more on the left hand side. So ionization potential, it will be less on the left hand side. Now similarly, metallic character is least on the right hand side. So ionization potential, it will be more on the right hand side. So similarly, if you are going down a group, metallic character, it is increasing. But since metallic character is increasing down the group, the ionization potential, it will decrease down the group. Similarly, if you are going towards the top, the metallic character, it will decrease. So since metallic character is decreasing, ionization potential will increase. Now I have explained ionization potential based on the metallic character, but actually you are supposed to explain everything based on either atomic size or nuclear charge. Okay, so I'm going to explain ionization potential based on the periodic terms of ionization potential based on atomic size and nuclear character, nuclear size, nuclear charge. So if you are this is what that is going to happen if I am moving down a group. Atomic size increases. Atomic size increases means nuclear charge, or the effective nuclear charge in the outermost shell, or for the outermost electron, it is less. Or in other words, the outermost electron is loosely bounded. So when we are having a increasing atomic size, definitely the ionization potential, it is supposed to be decrease. So if we are having more atomic size, less ionization potential. Now if we are moving from left to right in the periodic table, atomic size decreases. So atomic size decreases, that is due to increasing nuclear charge. So more amount of nuclear charge, less atomic size. In other words, it is not easy to remove the outermost electron from the valence shell. So in other words, ionization potential, it decreases when we are moving from left to right in a periodic table. Okay. Now, okay, just now we have studied about ionization potential. Similarly, we are having something called electron affinity, electron gain enthalpy. These are the two names, electron affinity and electron gain enthalpy. It is having a definition much similar to ionization potential. It is likewise, it is energy release. In some cases, energy absorbed also. It is not mentioned in the textbook. So it is the energy release when an atom which is in gaseous state absorb or gain an electron to the valence shell. Okay, so we are having an atom. So it is having many electrons in the other shells. So what we are going to do is we are going to give an electron to the valence shell of an atom. After absorbing that electron to the valence shell, it is going to release little bit amount of energy. In some cases, very large amount of energy. We are going to measure the difference in energy after and before this electron is added to the valence shell. That amount of energy, it is measured as electron affinity or electron gain enthalpy. Okay, so electron gain enthalpy is a measure of the energy that is released when an atom absorbs an electron. It is having some similarities with our non-metallic character, but it is just opposite in case of the trend. Okay, so if you are going across throughout the periodic table, you can see that the metal, it is not having any tendency to absorb the electron to the outermost shell. It is already having a tendency to lose electron. So metals, they will be having less amount of electron gain enthalpy compared to the non-metals. In other cases, non-metals are those elements which are having tendency to absorb the electron, so they will be having more electron gain enthalpy compared to that of metals. Just now we are studying almost all the metals, they are lying on the leftmost side of the periodic table. So on the left side of the periodic table, we will be having least amount of electron gain enthalpy. If you are moving from left to right in a periodic table, the electron gain enthalpy increases. So it is likewise, if an atom is having smaller the atomic size and larger the nuclear charge, it will be having high amount of electron gain enthalpy. In the opposite sense, if the size of the atom is big and nuclear charge, Ft nuclear charge is less, it will be having less amount of electron gain enthalpy. So in other words, if you are looking in the periodic table, the size of the atom, it is larger on the left bottom, smaller in the right toe. So it will be moderate in between. Okay, so if you are moving down a groove, definitely the electron gain enthalpy, it will decrease. Down a groove, electron gain enthalpy decreases. If you are moving from left to right in a periodic table, atomic size decreases, so definitely the electron gain enthalpy, it will increase. So today we will stop it here with this much of periodic trends. The first one that we discussed was atomic size, metallic character, non-metallic character, ionization potential. The last one is electron affinity. Okay, so we have discussed five of the 6 periodic trends. Only one is left over, that is electronegativity. And other than that, there is one important thing that I have to discuss, that is about the first and second ionization enthalpy and first and second electron affinity that I will discuss in the next class, and also the size difference, what is happening to the size of a cation and if it is compared to the atom, and also the size of an anion when it is compared to a normal atom. That much part we will discuss in the next class, and also just go through the live video once again. If you are having any doubts, go through the video more times. I hope you can refer some other textbook also. Okay, that's all. Thank you.